Hey everybody, this is Larry. This is day 18 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt, Decode race. Yeah, so I usually sub these live, so if it's a little bit slow, watch it on faster speed or something like that. Okay. I feel like I've done this problem recently, even on Leetcode Daily Challenge or whatever. Maybe there's another variation though. Let's see. So A to Z, there's a mapping from A to Z, decoding almost, okay. Okay. Yeah, okay. This feels pretty straightforward. So I think the version that's a little bit trickier is the version that's a little bit trickier is with a star or a wild card or something like that. But this one seems pretty straightforward. It's just that, yeah, if you're able to do that, then that should be okay. So I'm gonna start with dynamic programming, and the way that I'm gonna do it is top down, and basically you just take you have a choice at every index, right? At every index, you have a choice of taking one digit or two digits if it's possible, if the two digits are correct. So I think that's basically all we have to do. Yeah. Okay. So let's play around with that. Let's just say count of index. And if you're new to dynamic programming, I think this is a very good programming. This is a very good problem for doing beginners dynamic programming. So definitely practice this and make sure you understand this, because a lot of problems in dynamic program will build on stuff that you work on here, especially if this is one of your earlier problems. And one of the key thing is just compressing index, compressing the number of inputs from the S to from a string to a number, or from a string to an integer, because this is basically the prefix, right? What I would like to do is just really define the functions. In this case, I got a little bit lazy, but what I would say is that number of decodings of S of index, that means like the suffix of index including index. That's a Python index, so yeah. And then here you go, okay, if index is equal to n, then we return 1. That means that we used up all the characters properly. So let's just set n is equal to s as well. And okay. Yeah. And then now we go over it, and then here we go total is equal to 0, and then yeah, and then you go if we can take one character, right? I think this is the one that I usually mess up on, so that's why I'm a little bit careful. The if you can take one character is that you actually cannot always take one character, because it can be 0. That's mostly the only case, I believe. Yeah, because if it's 0, then you cannot take one character. So yeah. So actually, but even for two characters, the first character cannot be 0, so we can actually fast forward a little bit, which is that if s of index is equal to 0, oops, we return and we just return 0, right? Yeah. Okay. Otherwise, we can always take one character. So total, we do count of index plus 1, and then we do a if s of index is equal to 1 or 2. Well, actually, I guess the two cases, right? This is if we can take two characters. So that then, yeah, and the index plus 1 or plus 2 is less than n. Or plus 1 is less than n, then total index plus 2, if s of index is equal to 2, n index plus 1 is less than n, and s of index plus 1 is equal to, or is between is between 0 and what is it, 6, then total and of course you could do something smart to cache this, but for me it doesn't really matter. I'll just let the actual caching to do it, and then just return total. Yeah, and then now we just do count of 0. Of course this isn't quite so we're checking for correctness. Yeah, this isn't quite complete due to the fact that we didn't memorize, right? So before, let's just try this. And okay, so this looks good. We would be able to submit, but of course, given that n is 100, this would actually time out, as you can kind of see, if you do a longer string. Even this should be a bit long enough, but maybe I'm wrong. Oh, got 105. Well, okay. Well, then that definitely should be long enough. I just didn't count. Just kind of. Oh, okay. Well, in theory, that should time out, but I'm too lazy to actually find one that's the case. I think maybe you could. So that's the early of them, so yeah, it should time out in either case. Okay, wow, that doesn't time out. That's actually surprising. But you keep on adding it until it time out. I guess this is more Fibonacci, so I needed a couple of more ones. Okay, my point is that this would time out, and you need to use memorization. Also, do know that this should be a Fibonacci number, because all we do is do count of index plus 1 and count of index plus 2. So yeah, so this should be a Fibonacci number. But that said, either way, we have to remember to memorize. And how do you memorize? The idea behind memorization is that we have this function that if we given the same input, we'll get the same output. And in this case, that is true, right? Every time you get the same suffix, you get the same output. So that means that we can cache it, and this is the way that I usually like writing cache, at least for teaching. I like it to write, I'm just sending a 1 for, oh, I guess I could just write this. Oops. And has cache is equal to, let's just say 4 times n, and here we can do, okay, if has cache of index, return cache of index. Oops. Because this basically we're saying for this input, if we have the cache version, then we can return the cache. At the very end, we set the cache to true, and now we can run it again. Yeah, notice how much faster it is, and let's give it a submit. Cool. So now we ask ourselves, what is the complexity of this, right? Well, how many possible inputs are there? In this case, index can go from 0 to n, so there are O of n inputs. And for each input, we do O of 1 work and O of 1 space. So that means that in total we have O of n time and O of n space. Oops. That's pretty much it. Let me know what you think. I think maybe I could explain this part a little bit more, but I think this is a core dynamic programming thing. It's just trying to do recursion in a way, because now we take off 2 characters, and this is now the index that we're looking at, and this is another scenario where that is the case. But yeah. Anyway, that's all I have for today's problem. Let me know what you think. Hope y'all have a great week. Have to good mental health, and to stay good. Take care. I'll see you later. Bye bye.